Welcome to the Deep Dive. We're diving deep into the world of ticks and Lyme disease today. We've got this incredible YouTube video from TrueFacts Educational called Ticks, Educational Edition. It's seriously packed with amazing visuals, so we definitely recommend checking it out later. But for now, get ready to uncover some surprising facts about how ticks spread Lyme disease. And we'll even be busting some myths about deer along the way. Ever wonder what a tick's life is really like? Get ready for some pretty cool and maybe a little creepy insights. Let's imagine a tick. We'll call her Tina. Tina hatches from her egg as a tiny larva. She's barely bigger than a pinhead at this point.
You know, it's interesting. Even though ticks are arachnids, they don't start with 8 legs like spiders. Tina, as a larva, only has 6.
And here's something pretty wild. Tina is born completely Lyme-free. Tick mothers can't actually pass the Lyme disease bacteria to their offspring. So how does a tick like Tina end up with Lyme disease then?
Well, that's where Tina's first meal comes in.
Right, they need to eat.
Now, ticks don't have eyes, so they can't really hunt the way we usually think of it. Instead, they rely on this incredible sensory organ on their front legs called Haller's organ.
Oh yeah, I've heard of that.
It's like their superpower. It helps them sense things like body heat, carbon dioxide, even ammonia, which animals give off.
So they're just hanging out waiting for something to pass by.
Yeah, often on blades of grass or leaves, waiting patiently until a suitable host brushes by.
So it's all about being in the right place at the right time.
Exactly.
So let's say a mouse happens to wander by and Tina latches on. But this isn't just any mouse. This one is carrying the bacteria that causes Lyme disease, Borrelia burgdorferi. What happens next?
So this mouse is what we call a competent host. That means that the bacteria can live inside it without making the mouse sick.
Okay, so the bacteria are just hanging out in the mouse waiting for their next ride.
Yeah, pretty much. They need a way to get to other hosts so they can spread and survive, and that's where ticks like Tina come in.
Okay, that makes sense.
So as Tina feeds on the mouse, the Lyme disease bacteria make their way into her digestive system.
So it's like the bacteria are using ticks as their own personal taxi service to get around.
Aha, that's a great way to put it. The bacteria latch onto the lining of Tina's gut, and once they're there, they enter a low-energy state, almost like they're hibernating.
Ah, so they're just waiting for the tick to latch on to another host.
Yeah.
So what happens to Tina after she's done with her meal?
Well, after a few days of feasting, Tina's gotten pretty engorged with blood. She drops off the mouse, digests her meal, and molts, transitioning into the next stage of her life, the nymph stage.
So is that when she finally gets her full set of 8 legs?
That's right. And just like any growing teenager, she's gonna need another meal.
So this is where we bust a common Lyme disease myth. I always thought deer were the main culprits for spreading Lyme, but it turns out they're actually not.
You're right, that's a big misconception. Deer are what we call incompetent hosts.
Incompetent.
What that means is, if a tick feeds on a deer, the deer's blood actually clears the tick of Lyme bacteria.
So feeding on a deer is a dead end for the bacteria.
Exactly. They need to find another competent host, like a mouse or even a human, to continue their life cycle.
Wow, interesting.
And while humans, like deer, are also dead-end hosts, we're the ones who experience the negative consequences with Lyme disease.
Makes sense. So how exactly does a tick feed? It's not as simple as just a mosquito bite, right?
No, it's not. Ticks are what we call pool feeders.
Pool feeders.
Yeah, instead of just piercing a blood vessel, they dig into the skin and create a little pool of blood to feed from.
So it's like they're creating their own little swimming pool of blood.
Ha, pretty much. They use these specialized mouth parts to do this. First, they use their chelicerae, which are like tiny little pincers, to cut into the spin.
And then they have that harpoon-like structure, the hypostome, to help them anchor themselves in, right?
Exactly. The hypostome has these backward-facing barbs that really help them hold on tight.
Wow. So what about their saliva? What's so special about that?
Well, it contains all sorts of interesting compounds. It acts as a numbing agent, so the host doesn't even feel the bite. It also has anticoagulants to keep the blood flowing, and even compounds that suppress the host's immune system.
Wow, so they've got a whole arsenal of tricks. But I thought the Lyme bacteria were hanging out in the tick's gut. How do they get into the new host?
That's a great question. This is where things get even more intricate. During feeding, the Lyme disease bacteria actually migrate from the tick's gut to its salivary glands.
So they travel through the tick's body.
Yep, and it's through the saliva that they're transmitted to the new host. It's an incredible adaptation that allows the bacteria to spread and survive.
So that's why it's so important to remove a tick as soon as you find it.
Exactly. Removing a tick within 24 hours of attachment can significantly reduce the chances of getting Lyme disease. It takes time for the bacteria to move from the gut to those salivary glands. So the sooner you remove the tick, the better.
Makes sense. So back to Tina. She's had her second meal as a nymph. What happens next in her journey?
Well, after that second meal, she's ready for her final molt. This is when she transforms into an adult tick.
And are there differences between male and female adult ticks?
You're absolutely right. Female ticks are larger and have a greater capacity for blood meals, which is important for their egg laying later on. Male ticks, on the other hand, have shorter mouth parts and don't actually feed as adults.
So what do the males do if they don't feed?
Well, they have one main purpose: to find a female and mate. And the mating process is pretty unusual.
Oh, I bet. Tell me more.
The male tick actually uses his mouth parts to transfer a spermatophore to the female. Think of it like a little package of sperm.
Wow, so no romantic dinners for ticks.
Not quite.
So once the female is fertilized, what happens?
Well, her one and only mission as an adult is to lay as many eggs as possible to ensure the survival of the next generation. And to do that, she needs one last massive blood meal.
How massive are we talking?
We're talking about a truly incredible feat of biological engineering. A female tick can increase her weight by up to 200 times during this final feeding.
200 times. That's like me eating my weight in food every day for weeks.
Haha, it's amazing, isn't it? And to make sure all those eggs are protected, female ticks have a special organ called Janie's organ.
What's the Janie's organ do?
It's responsible for coating the eggs with a special waxy secretion that helps them stay together and keeps them moist, which is essential for their development.
It's like a little built-in egg protector.
Exactly. Tina, our dedicated tick mom, can lay up to 2,000 eggs. Once she's done, she completes her life cycle and dies.
Wow, what an incredible journey. From a tiny six-legged larva to a mother of thousands, Tina's life was all about survival and ultimately passing on her genes to the next generation. So we've learned all about Tina's life cycle and how ticks feed and transmit Lyme disease. But I'm curious, what are some of the most common misconceptions people have about how ticks hunt and find their hosts?
That's a great question, and I'm happy to clear up some confusion. A lot of people think that ticks jump or fly, which isn't true at all. They don't have wings and can't jump very far.
Yeah, I remember hearing that ticks fall out of trees onto people, which sounds pretty terrifying.
Haha, that's another common myth. While they can climb, they generally don't live high up in trees. They prefer to stay closer to the ground in areas with tall grass, leaf litter, and shrubs where they can easily access potential hosts.
So it's all about being in the right place at the right time for them.
Exactly. They use their Haller's organs to sense when a host is nearby, and then they quest, which means they extend their front legs and wait for something to brush by. They're not actively pursuing hosts, they're more like passive ambush predators.
That makes a lot more sense. So those Haller's organs are pretty crucial to their survival.
Absolutely. It's their way of navigating the world and finding their next meal.
Well, this has been incredibly insightful. I'm already starting to rethink my whole approach to tick prevention. But before we get into that, I want to hear more about these Lyme disease bacteria. Their life cycle is just as fascinating as the ticks themselves. So let's take a closer look at Borrelia burgdorferi. How do they manage to survive and thrive inside both ticks and their hosts?
That's a great segue into the next part of our discussion. Borrelia burgdorferi is a type of bacteria called a spirochete. They're spiral-shaped and have this amazing ability to move through different environments.
Spiral shape like a tiny corkscrew.
Exactly. That unique shape allows them to move easily through viscous fluids like blood and tissue, which helps them evade the host's immune system.
So that's how they manage to stay hidden inside the host's body.
That's part of it, but they also have other tricks up their sleeve. They can actually change their outer surface proteins to avoid detection by the host's immune system.
So they're constantly adapting and evolving to stay one step ahead.
Exactly. And their ability to go dormant, like we discussed earlier, is another key survival strategy. When times are tough, they can essentially shut down their metabolism and wait for better conditions.
That's incredible. It's no wonder they've been so successful at spreading and causing disease. But tell me more about how they interact with the tick's immune system.
Well, what's fascinating is that the tick's immune system doesn't seem to bother the Lyme disease bacteria at all. They've evolved to coexist peacefully, almost like they have a symbiotic relationship.
So the tick isn't negatively affected by carrying these bacteria?
Not at all. In fact, the tick's immune system may even play a role in helping the bacteria survive.
That's amazing. It sounds like these bacteria have mastered the art of manipulation, using both ticks and their hosts to their advantage.
Uh-huh. That's a great way to put it. They've evolved these remarkable adaptations that allow them to thrive in this complex ecosystem.
It really makes you appreciate the intricate web of life, doesn't it?
It certainly does.
Well, we've covered a lot of ground today, but we're not done yet. Coming up in part 2 of our deep dive, we'll explore the symptoms of Lyme disease and dive into the latest research on prevention and treatment options. You won't want to miss it.
It's pretty amazing how these tiny organisms can have such a significant impact on our health, isn't it?
It really is. And speaking of impact, let's talk about Lyme disease itself. What happens if a tick carrying Borrelia burgdorferi bites a human? What kind of symptoms should people be looking out for?
That's a crucial question. And early detection is key when it comes to Lyme disease. One of the most common early signs is this characteristic rash called erythema migrans.
I've heard of it as that bullseye rash, right?
Exactly. It often appears at the site of the tick bite, and it gradually expands, resembling a bullseye or a target. But it's important to note that not everyone with Lyme disease develops this rash.
So what are some other symptoms that people should be aware of?
Well, in the early stages, people might experience flu-like symptoms, such as fever, chills, headache, fatigue, muscle, and joint aches. Some people also experience swollen lymph nodes.
So it can be pretty tricky to diagnose, especially if the rash doesn't appear. It sounds like it could easily be mistaken for other illnesses.
That's one of the challenges with Lyme disease, yeah. If it's not caught early, the bacteria can spread to other parts of the body, leading to more serious complications.
What kind of complications?
Well, if left untreated, Lyme disease can affect the heart, causing irregular heartbeat or inflammation of the heart muscle. It can also affect the nervous system, leading to things like facial palsy, meningitis, or nerve pain. And in some cases, it can even cause arthritis, particularly in the knees.
Wow, that's a pretty wide range of potential problems. Sounds like early detection is really crucial to prevent these more serious complications.
Absolutely. If you've been bitten by a tick and experience any of these symptoms, it's important to see a doctor right away.
So how is Lyme disease diagnosed?
Diagnosis usually involves a combination of factors, including a physical exam, reviewing your symptoms, and medical history, and most importantly, blood tests.
So there are specific blood tests that can detect Lyme disease.
Yes, but these tests are most reliable a few weeks after the initial infection. This is because it takes time for the body to produce enough antibodies to be detected by the test.
So if someone gets tested too early, it might come back negative even if they actually have Lyme disease.
That's possible. That's why it's so important to consider all the factors, not just rely on the blood test alone.
It sounds like it's a bit of a detective game to accurately diagnose Lyme disease.
It can be. But thankfully, if caught early, Lyme disease is very treatable with antibiotics.
That's good to know. So what does treatment typically involve?
Most cases of early Lyme disease can be effectively treated with a 2 to 4 week course of oral antibiotics. In some cases, especially if the disease has progressed, intravenous antibiotics might be necessary.
So even if someone develops some of those more serious complications we talked about, there's still hope for recovery.
Yes, absolutely. The sooner treatment is started, the better the chances of a full recovery. But even in cases of late-stage Lyme disease, treatment can help manage symptoms and prevent further damage.
That's encouraging to hear. But I imagine there's still a lot we don't know about Lyme disease.
That's true. Lyme disease research is ongoing, and scientists are constantly working to better understand the bacteria, the disease process, and how to improve diagnosis and treatment.
I'm curious, what are some of the most exciting areas of research in the field of Lyme disease right now?
Well, one area that's generating a lot of interest is the development of a Lyme disease vaccine.
A vaccine? That would be amazing.
It would be a game changer. There was actually a Lyme disease vaccine available in the U.S. for a while, but it was withdrawn from the market due to low demand and concerns about side effects.
Why was the demand so low?
Well, there are a few factors at play. The vaccine wasn't 100% effective, and people still needed to take precautions against tick bites. Also, there were some unfounded fears about the vaccine's safety, which unfortunately spread quite widely.
So it's back to the drawing board for a new vaccine.
Not exactly. The technology and understanding of Lyme disease have advanced significantly since then. Researchers are now working on new vaccine candidates that are more effective and have a better safety profile.
That's promising news. What about other areas of research?
Another fascinating area is the study of chronic Lyme disease, also known as post-treatment Lyme disease syndrome.
What is chronic Lyme disease?